Alright guys, so we are going to cover Chapter 7, which is all about networking. Learning objectives for this chapter include describing computer networks and their pros and cons, talking about the different ways networks are defined, describing the types of transmission media that's used in networks and what transmission media is, describing the basic hardware devices that are necessary for the networks, talking about the types of software that are necessary, summarizing broadband options that are available to access the internet. Also talk about accessing the internet wirelessly. Explain what should be considered before creating a home network. Tell you how to set up a home network. Summarize how to configure home network software. Describe the potential problems with wireless networks and the means in which to avoid them. Describe how to secure your wireless home network. This one's really important. Okay. And so when we're talking about a computer network, it's simply two or more computers that are connected via software and hardware so that they can communicate with each other. Every single device on a network is considered a node. Okay. A node doesn't just have to be a computer. Okay. It can be your phone. Okay, so when you go home and your phone connects to your network, your wireless network, any sort of peripherals, so things like a printer, or maybe you have wireless speakers. Okay, like an Alexa device, any of the home. Sorry, I'm forgetting the term right now. The home assistants, okay, like the Google one, Google Home, you have Amazon Alexa, those types of things. Any of those that connect to a network are considered a node. All right? So here's an example. Okay, this picture is from your book. All right, so I actually really hate this picture. Slightly stereotypical, okay, but here we have Dad sitting down, of course, right, watching a movie while he's checking fantasy football scores on his iPad. Okay, here is the daughter throwing a frisbee to her dog while she takes pictures of her dog and is uploading them directly to Facebook. Okay, brother is up here playing PlayStation online, uploading a video he made for school. Here you have Jackie, who looks like she belongs in the Kardashian household, right? But watching a video she took while on vacation. And here's Mom in the kitchen, watching a lecture from her online course while she prepares a snack. Okay. Yes, so anyway, the point of that picture is that everyone represented there is basically a node in this household network. Okay, they're all using the network. I imagine their network is probably relatively slow, especially if they live in Vegas, where your max speed is like topping out at 12 megabits per second. Okay, gosh, I sound grumpy today, don't I? I apologize for that. So anyway, computer networks and nodes. Okay, so why do we use networks? What are the benefits of them? There's a lot of benefits, okay? I'm sure you can think of a bunch on your own, but these are our technical reasons that we use networks. Okay. Sharing an internet connection is like the #1 benefit, okay? Network lets you share that internet that's coming into your home, right? Sharing printers and other peripheral devices. So at home, say, like in my house, for example, I have a wireless printer. Sits far off in its own little corner because nobody wants to look at a printer, right? But the whole household can access it. It's from the desktop or from the laptops or from the phones, that kind of thing. Okay, so that's a nice bonus of just having to have one device, especially if you're not necessarily with family. Okay, maybe you're with roommates and maybe one person happens to have a printer and they're like nice enough to let you use it. So not everyone has to go out and have their own device. You can also share files. Okay, obviously we're sharing files constantly. Then common communications. So computers running all kinds of different operating systems can communicate on the same network. It's not just like the Windows network or the Mac OS network or the Linux network. Okay, everyone can communicate using the same internet connection. Major disadvantage of networks, setup time. Okay, and I hesitate to even call it a major disadvantage. I mean, how long, honestly, does it take to set up your home network? Not long at all, right? Unless you have to troubleshoot and have some issues, then it can take some time, but usually it doesn't take very long. The other issue is administration, and this doesn't necessarily apply to our home networks. This is more of when you have business. Okay, so you actually have to employ someone to be in charge of your network, and they call them network administrators. Okay, so there's a job for you right there. System admins. They're in charge of what's going on with the network. So making sure the network is working, making sure it's working like throughout the location it's supposed to be working in. Okay, that all the nodes on the network are connected, like lots and lots of different things to consider. Those are some disadvantages of networks. But like I said, most of those really apply only to like a business setting. So how does data actually move through the networks? Okay. These terms here will help us to understand how the data moves, right? We have something called bandwidth. So you'll hear that term a lot. They're using all the bandwidth, okay? What it is just your data transfer rate. And that's the maximum speed at which your data can be transmitted. Okay, so let's use my example from earlier. From Grumpy Time example. Okay, so for example, I have CenturyLink for my internet at home, and my promised speed, or not promised, the maximum speed that I can attain would be 12 megabits per second per CenturyLink. Okay, that is the bandwidth. Okay, now throughput is the actual speed at which data is transferred. And in my house, at least according to, you can run these tests online. You can check out your bandwidth. Your throughput. See, I'm mixing up the terms. I'm actually running more at like 2.9 megabits per second. So like 10 megabits per second slower than the promised 12, right? So now you can see why it irritates me. And throughput, so let's remember the difference. Throughput is the actual speed at which data is transferred. Bandwidth is the maximum speed at which your data can be transmitted. Okay, and as you've been hearing me say, this stuff is measured in megabits per second. So you'll see it big M, small b, small p, small s, or gigabits, which is, of course, a lot faster. Big G, small b, small p, small s. Okay, so we're not talking about megabytes or gigabytes. We're talking about megabits and gigabits. And you'll see gigabits when you're using fiber. Networks can be classified by distance. All right. So these are some different terms. Okay. PAN is a personal area network, and that's used for communication among devices that are close to like one person. So you and your phone and maybe your tablet or something. Okay. Excuse me for my cough. There's why this is late coming to you. I can't shake this stuff. Okay. But I have a voice, so we're good. Local area network, or a LAN. Okay, you hear about these a lot. Local area network, it's just a network in which the nodes are located within like a small geographical area. Okay, and so you can see this here, little visual here for you, that's in your book. Okay, HAN is a home area network, so that's a network like inside your house. A MAN is, contrary to popular belief, a metropolitan area network. Okay, so that's going to cover like a city. Okay, Some cities, believe it or not, actually offer free internet to all of their residents and tourists that come through. So we refer to that as a metropolitan area network. And finally, we have a WAN, which is a wide area network, and this spans a large physical distance. Have any guesses about what the largest WAN is? The internet. That's the biggest network, right? It spans the whole entire globe. Sorry guys, I had to check my recording time. I'm limited to 15 minutes per session. All right, continuing on here with network architecture. Okay. We can also classify networks by their levels of administration. Okay, so like I talked about earlier, we have client-server networks and we have peer-to-peer networks. All right, client-server networks. A client is the computer on which your users accomplish tasks and make requests of the server. Okay, the server is the computer that provides information or resources to the client computers. So, for example, if you are here on campus and you are listening to this lecture, doing your homework, whatever you happen to be up to, you're using a client-server network. Okay, this is a large network we have here on campus. And so, if you use a lab machine or even your own machine, okay, here, and that's the client. And anything you do, you're sending requests to Highland's servers. These guys right here. Okay, the service will fulfill your requests and then return whatever you request back to you. So what does that mean in English? Basically, you open up your computer, you log on to the network, okay, and you start using the internet. Anything you do will be sent to the server, okay? Say you want to come to the Highlands website, okay? Type it in, click on it, that request gets sent to the server. Server says, okay, this IP address is requesting the Highlands homepage. I'm going to fulfill that request, send it back to that machine, and voila, you see it on your screen. All right, peer-to-peer networks are much smaller networks. Every single node on a peer-to-peer network can communicate with another node on that network directly. Okay, so not going through a server like we have here. So X out that server because here we don't have a server. Everyone is equal in a peer-to-peer network, okay? You have your all your different nodes, so like your phone, printer, desktop, laptop, tablet. All of those can connect and communicate directly with one another. Okay. We can also classify networks by the protocols that are used. So we have Ethernet. Okay. This was developed by IEEE, which is the Institute of Electrical and Electronics Engineers. This applies both to wireless and wired networks. Okay, so that's our Wi-Fi, as well as our gigabit and Ethernet, which we denote here by big G, small b, big E. Okay. Another term that we've covered before, that was thrown in here because sometimes you'll hear it when you're talking about networks, is backwards compatibility. Okay, as our transmission media improves, we want to make sure that people using older media are still able to, use that stuff. Okay, and so make sure everything's backwards compatible. So, for example, I'm using like a better version of an Ethernet cable or whatever than you are. That's just due to, this is the one Highlands gave me, or the one that you happen to have, or maybe you bought yours at the thrift store, or I don't know what. Okay, it's going to work regardless. Okay, when it gets to the point where they're like, okay, anything beyond this point is no longer going to work, that's when the backwards compatibility ends. So if you remember, I don't know, 10 years back at least, when they got rid of TV antennas. I know I'm dating myself here, guys. Okay, they said, okay, no longer these like rabbit ear kind of antenna thing's going to work, you're going to have to update to this certain type of antenna. Or okay, people were sort of upset